Let's test out this constant current electronic load. This unit was sent to me at no cost from Banggood, and I wanted something that could handle a lot of power, so I chose this 200 volt 20 amp 180 watt unit. I'll put a link below so you can check the specifications and features, but I'll test out a few things I am able to test, some things I'm not, such as supporting Qualcomm QC 2.0 and 3.0 quick voltage. I don't have any QC capable devices, but if you have an extra QC2 and 3.0 trigger board, you can use it with this load to get into those different voltage modes. So I'll test out a few things and also evaluate the user interface with the display and the buttons and dials, go over what's on the board. We'll look at what seems to work well and what could use some improvement on this unit. It comes with a couple of test leads. There's this USB plug with a couple of alligator clips, and then a couple of bare wires with alligator clips. We also get a 9 volt 2 amp wall adapter that can take 100 to 240 AC, so this 9 volt supply plugs into the back of this unit to power it. Then we get some instructions, but it doesn't tell you everything, and I had to figure a lot of things out myself. The specifications, these directions for getting into different modes, and a sort of a quick start guide and a warning. So this function key they are talking about with all of these modes, there's one button right here, and then there's two potentiometers to control the current setting. And the instructions say before you use the load, turn both the fine and coarse down counterclockwise, so you start with no load current. So here's the heat sink. It's got a fan on the front and the back. The heat sink in here measures 4 centimeters square, and the big power transistor is down in there, but I can't see what it is. So starting at the back, the power for the unit itself is 6 to 12 volts, and they give you a 9 volt adapter. Those current shunts are in series with the ground path of the inputs to the load. This DC output jack over here has its plus terminal wired directly to the positive terminals on the input of this tester, and the ground of the output jack comes down here to this side of the current shunt, and then through the shunt it would connect to the ground of the input. So it looks like if we have a power supply providing power to this load, then we plug in something else on this output and it draws some current. It will draw it from the main supply we are testing, and because its ground current is going through these shunts, the extra load current from this output jack is also monitored by the system. So on the left side are all the inputs. We can either hook up the positive and negative terminals to these screw terminals, or this standard DC jack input, or all of these regular USB connectors. For all these USBs, it seems like the power and data are all in parallel, so you just choose which one you want to use. And on the bottom of the board, there's a reminder it's quick charge trigger input. Now, I don't have a quick charge power source or one of those USB quick charge trigger devices, but I will link to one below. There's not much to see on the bottom side. Here's the load section. The power transistor for the load is here on the top side. A lot of heavy power traces. This is where the display cable plugs in. To get started, I have a 5 volt 1 amp USB mini charger, and we see 4.98 volts, and let's start consuming a load current. So we're drawing half an amp and the fan comes on. And this is actually a good application for using this electronic load. We can see our 4.98 volts is now sagging as we approach higher currents. So if this is supposed to be a 1 amp USB charger, can I get 1 amp without this totally sagging? When we get to 0.87 or so amps, our voltage went down to 0.83 volts. Yeah, we go above 0.85 amps, and our voltage is really starting to drop a lot from the 5 volts. So we've tested a USB power supply already. Now I have a 9 volt 800 milliamp DC supply. I believe it's unregulated. So the instructions say always make sure the dials are counterclockwise for no load current when you connect up a power source. So this 9 volt adapter starts at 12.5 with no load. Drawing half an amp, it's switching around between 9.5 to 11 volts. So I'm already drawing more than it's rated for. I'm drawing just over 1 amp. It's jumping around between 7.2 and 10 volts. Maybe that's something I want to look at in the future on the scope. In the meantime, if I turn this load down, I can draw about 1 amp with this power resistor on this DC output jack, which is connected with the DC inputs. So I'm adding an extra load. So no load from here, and now I can draw an external load. So I've got just over 1 amp, and we're doing the same thing on the voltage, jumping between just over 7 to almost 10. I'm not really sure of the use case of having this external load output. Maybe if I researched electronic loads more, I could figure that out. But for now, I've taped a thermocouple to an access point on the heatsink, trying to get it as close to the center and top as I could. One thing the instructions say, if you hold down the button and then plug it in, you'll get into a certain configuration mode. So I can press the button once and flip through these settings. I'm not sure exactly what all these settings mean. Maybe this is an offset for voltage, but we don't have any load, so it should be 0 volts. These are cutoffs, so if we exceed 6 volts, or I can change it, this will shut down and give a warning. But I believe it only shuts down for several seconds and then it will try again. And if it's still exceeding 6 volts or whatever it's set for, it'll just shut down for a couple seconds again. And there's a JST looking connector over on the side here that gives out a voltage while in error mode, so you could detect this from some other circuit. And this is the lower threshold, so 0 means there is no low threshold. But if I'm discharging a battery and say I want to not go beyond 1.1 volts, I could set this. So let's do that. It looks like 2 clicks increase this, 1 click decreases this. And if you hold it down, it will go faster in whatever direction you're currently going. So if you do nothing, it will time out and accept what you've entered. Now I can do a single click to go to the next config. So now if we exceed 2 amps of current draw, it will give us an alarm. I'm not sure what this looks like, a scaling factor. I'm not sure what this does. And we can have it cut off as well if we exceed a certain power. I set it so that for now, if we exceed 70 watts, we will also get an alarm. So right now, it's showing 10 milliamps, but we don't have a load. So is this where I would set an offset? So I just clicked the buttons until this actually went to 0 amps, and that's all we can set. Then it goes back to the first setting, and I cannot find a way out of here. The only way I know out is if you hold down the button, it'll reset all of this to factory defaults and then quit out to the main menu. And it does appear to retain settings when you unplug it. So I guess we have to cycle the power. Welcome screen. And it detects, of course, we have no load, so we're less than 1.1 volts. So while it's in error mode, let's probe this output pin. So we have a 3 volt output while we are in error mode. So I'll give it a couple of volts. Now it's 3.7 volts, and we have 0 volts over on that fault header. So I'm turning the voltage down with my finger off screen, and we go into error mode and we get 3 volts on that test output. Turn it back up, 4 volts or so, 0 volts out. There's the voltage control. I was holding the probes and trying to adjust that at the same time. So if we exceed 6 volts, we go into error mode as well. So we tested the over voltage works, under voltage works. So let's try the 2 amp current limit we set. Make sure the fine and coarse load current dials are down all the way counterclockwise to draw no load to start. Then start with the fine if you're only going to draw a small amount of current. So I'm drawing 400 milliamps. I want to get up to 2 amps. The fan comes on when you draw half an amp, or when you exceed a certain temperature, 45 degrees Celsius. So right now, this display says 24 degrees Celsius, and I'm getting 25.7. I'll keep adjusting the current. And because I'm just using thin alligator clips, I am getting a voltage drop, but that doesn't matter for now. I just want to get to 2 amps. So it does an alarm, it shuts down, there's no load right now and the fan is off. But then it kicks in again and tries to draw that load. It realizes it's exceeded 2 amps, so it keeps cutting in and out. I think I would prefer if this would just completely stop until I come and reset it, because if there's a fault, I don't want it to keep powering up. And if I'm testing a battery discharge, I don't want this to detect a lower voltage than my preset, and then it keeps trying to draw load. We've started accumulating some power data here. We have 1.88 amp hours, and we've accumulated some time here. We are still drawing a load, 30 milliamps it says, but the timer is not running. It seems like if I draw more than 0.5 watts, that's when the timer kicks in. So I'm not sure how all that is configured. And I can't find a way in the instructions or online to figure any of that out. So if I did want to start a new test, I've already got this data. You just hold the button and it should clear all this data. Okay, so now we are currently drawing 0.58 watts. Our timer is counting because it's above 0.5 watts, and it started at 0, and we have 0 amp hours and watt hours. And while we are in this main screen, we press the button once and we can cycle through, backlight on or off. If we press 3 times, we can start putting a timer on here where the backlight will go off, 59 seconds, and you just don't press anything and it will time out and go back to the first menu to show it's set it. So I cycle through again. I want this to go back to just on, so I press it twice, it goes upwards and hits the on mode. 3 times, it'll start going backwards, and I guess I can get this down to a couple of seconds or keep it fully off. Go through the menus again. I can choose whatever display layout I like. Otherwise, after backlight, there's our settings for the thresholds that we set when we powered up holding down the button. We can also get to it just while running a test. Upper and lower voltage limits, current, power, and then back to the first menu. So while testing, if we want to change to a different cutoff threshold, we can just cycle through the menus. This has a resistance measurement, which would be a calculation based on the voltage and current measured at these input terminals. So that could tell you the internal resistance of your power source under test. But we don't have a 4-wire voltage measurement here. So if I have a voltage drop between my power source through the cabling down to here, if I had 4-wire measurement, there would be 2 more wires I could bring directly to my power source, measure the voltage right at the source without the loss, and that would actually be a better calculation. So I'm not sure how meaningful that resistance measurement is with only a 2-wire measurement. Now I have heavier leads. These are 18 gauge going to the power supply, and in series with one of those is a current meter, and I have a voltmeter across the voltage terminals right here, so we can measure what this unit is also measuring. The specifications say the voltage and current measurement accuracy is 50 millivolts and 50 milliamps, but it's showing that across the full range, 0 volts to 200 volts and 0 amps to 20 amps. So of course here we're showing 0 volts and we're measuring about 70 millivolts already, more than 50 millivolts difference between the meter and this unit. So given that this is a higher powered load, if I really wanted this to test battery discharge, for example, with 1 volt and 100 milliamps, I don't know if this unit is what I'd use. I wanted this unit for higher power stuff. So those specs may not matter, but I thought we could just look at them. So we're starting out at 25.8 degrees Celsius on the thermocouple, 24 degrees Celsius on this unit. I changed the voltage and current thresholds to allow me to put in what I want. I still kept it with a 70 watt cutoff though, so I can test that. So let's just try putting some load. When I put in a couple of 100 millivolts, it looks like it's off by 90 millivolts. So if I keep increasing the voltage, and we have no load current, we're just setting voltage. When I get to 0.6 volts, 0.616 to 20, and I get 0.60 here, 3.65, 3.62, 11.03, 10.9, 23.37, and 23.3, 0.014 amps, and we don't have enough decimals here, so we're at 0.01 amps, 0.105 amps, and 0.10, who knows. 1.38 amps, 1.38 amps. The thermocouple is now showing 31.9 degrees, and we have 31 degrees here on the unit. So right now, 38.5 watts. I'm going to turn up the fine current adjust. We are set to shut down at 70 watts. 65. And greater than 70 watts. It gives us our alarm. It temporarily shuts down, but then it tries to run again and sees we're drawing too much. So let's allow it to draw more power and see how hot it gets. So let's draw as much current as we can. The best I can do with my power supply right now, 28.5 volts, 5.2 amps. It's showing 147.65 watts. Right now we're at 57 degrees on the unit, 48 degrees where my thermocouple is. So air is being drawn in the front fan and blowing out the back, and it's not really feeling hot back there, but it is hot to touch on these pegs up here on top of the heatsink. I can only hold this for so long, and now it's too hot to touch. But the main metal parts here, it's just warm. And when I touch this unit, these probes are just barely jammed in. They're not tightened down, so sometimes the voltmeter is going to jump around. So I've been running this at 149 watts. It seems the temperature on the unit is leveling out around 60 degrees and close to 50 degrees where I put the thermocouple. So that's about as much current as I can deliver. I should be able to get close to 60 volts with my power supply though, so let's increase that. And I can get up to 59.6, and it's showing 59.6. Draw some current. So I can get 58.3 volts and 58.4, 2.8 amps, 2.77 amps, close to 160 watts, close to 60 degrees, close to 50 degrees. So I've given it the maximum current and now the maximum voltage I can do. And it seems to be able to handle that, no problem. I set up a small battery discharge test with a AA rechargeable NiMH 1900 milliamp hour capacity, and I set it to warn me when it goes down below 1.1 volts. I set the camera toward the end of the discharge cycle to take a picture every 15 minutes. So somewhere between 8 hours 49 minutes and 9 hours 4 minutes, it reached below 1.1 volts and started doing a warning beep and printed out the notice on the screen. I set the load to about 200 milliamps and it measured 1760, so that's pretty close to the 1900. But since the test doesn't completely stop and it keeps trying to go back to running the load, I would want to make sure I'm around when the test is done so I can check the timing myself and turn it off. So, final thoughts on this DC electronic load. The pros, it does have a lot of input connectivity options, including of course bare terminals, but all these USB connectors and this DC jack, and it does support a USB quick trigger input for QC 2.0 and 3.0. Handles a lot of current, voltage, and power for its general cost and size. It does have 2 fans and a big heatsink to help dissipate all that power. And it seems to pretty much do what I expected it to do and what I wanted it for. Just being able to have a constant current at a relatively high current and voltage for general bench lab work without trying to do anything too specialized. So if I need to get a quick couple of amps and I need to work with some obscure voltage, this should be able to handle it. The cons, well, I don't feel fully confident leaving this unattended, so it does require full attention, I feel. You don't want to risk the fan breaking and then this thing overheats. And if you're doing a battery discharge test, if this doesn't truly stop drawing current once the battery voltage has gone to a lower threshold, if it keeps trying to kick in, it's not really what we want, so we need to be around to hear the alarm or see the screen. So it does require some monitoring. It's not a full standalone unit. So it's not one size fits all. And because it's capable of doing so much power, it's not necessarily well suited for lower currents and voltages. The accuracy at low current and voltage may be out by too much to be very accurate for doing battery capacity on just a 1.2 volt cell and trying to do a consistent load for several hours. This may fluctuate all over the place and impact the readings. But if you're draining a much more powerful battery pack, maybe this is perfectly fine. It seems to be meant for high power. The instructions are really not very good. I feel like there's a lot of hidden features and menu options that I don't understand how to use and the instructions don't address. It would be nice to have documented what this output pin here is for when a test is in error mode and why we would want a DC output jack. So the user interface is not very clear itself. When we are going through menus, it would be good to have a little more information. Instead of just like greater than 120V, it could say upper threshold voltage or something, or upper cutoff voltage. Once you know what it means, it's obvious, but the first time through using this, it can be overwhelming. And having only one button for control and having to do up to 7 button presses at a time to get a certain function, having to know and memorize if you don't have the instructions, you're supposed to hold this down or click it a certain number of times to do something. It would at least be good to have 2 buttons, one for up and one for down, and then use alternate functions for mode switching and such. I feel there may be software bugs in here as well. For example, that timer on the screen only starts counting when we are drawing more than half a watt. So I'm not sure the reason for that or if it's a bug, because if I'm drawing less than half a watt, I'm still drawing something and I want to be timing that. So I feel like I have to add my own stopwatch. I also feel that when a limit is set for under or over voltage, over current, excessive power, once that limit is reached, it should stop testing and stop applying the load to the power source. Either because there's a genuine fault and we don't want this to be trying to draw power, or because everything's fine, the test is done, we don't want to continue drawing power. So again, we have to be on standby to manually oversee what's going on. But as I said, overall, I wanted this just to be a standby high power load that I never meant to leave unattended anyway, so it will do fine for what I want. But if I'm going to do anything like lower voltage, lower current battery capacity testing, or maybe even USB quick charge, I might just get a dedicated USB quick charge tester. So if you're shopping for a DC electronic load, I don't believe so far in this kind of low cost budget range, there is one size fits all. So if you need one with a lot of power handling, this may be for you. Thanks again to Banggood for sending this to me to evaluate. So I hope this review was helpful, whether because you already have something that has a similar interface and you weren't sure how to use it, or because you're shopping around and wanted some info on this particular style device.